Okay, today we're going to go over a tool called Backdoor Boy. Let me scroll on up so you can see that. Okay, so there's a few tools or a few capabilities of this binary. It works on Windows, Linux, and so far works great on Mac, Darwin. But anyways, yeah. What we'll cover is bind shell, reverse shell, and a SOCKS5 proxy using bind and reverse shell. So again, TCP streams. We also will go over file transfer if we have enough time. Depends on how much time I can have. Anyways, yeah, do all this fun stuff. The tool, again, just GitHub, Backdoor Boy. I'll include a link. The release, I didn't include binaries, just so you can build it from source. If you look at the workflows, that should have the build instructions. So anyways, yeah, let's start with the bind shell. We're going to use Kali Linux for this first part. We have one container here, we have one container here, and you can see the IP, .3 and .4. Cool. So we'll pull up the help menu, and you can see we've got a few capabilities. A few of them don't work, but I can tell you netcat, proxy, and file transfer work great. So let's go ahead and go into netcat. Here's the other help menu. So what we're going to do is we're going to do address. We're just going to copy this guy. Let's do port 8080. We're going to be the caller. Let's see. I think we'll leave everything as is for now. Okay. Netcat. Okay. And this will be our bind. Okay, leave that as is. And actually, while we're doing that, let's go ahead and get Wireshark up and running just so you can get an idea of what this looks like over the wire. So kick that off. Who am I? LS, right? All that fun stuff. Let's follow this TCP stream. And you can see, yeah, plain text. Let's kill that. Okay, so as you see, we're here. This is our server pod, right? And it's not relying on much. We do need bash on there. If that's not on there, I do have another repo where you can build bash from source, use the file transfer to upload it, and then use bash standalone. Works great. Okay, so I got this problem. Hang on real quick. Exit. Oops. Okay, I'm going to respin up this pod. Once in a while that happens. Okay, sorry, spin up this container. We're not on Kubernetes, my bad. And we just need the IP address. So now we're .2. Probably should remember that. Okay, now what we're going to do is we're going to do this with TLS. Sorry, 1 second. TLS. So before we kick this off, let's go ahead and go, save it, open up our listener, send it. Who am I? Oh, that's right. Different IP. My bad. There we go. Who am I? LS. Go all the way down here to a port 8080. Let's follow that one. And as you can see, encrypted. Great. That's our bind shell. Go ahead and dump that. Okay, now let's talk about a reverse shell. In this case, this is going to be our compromised container. We're going to do reverse. We need the address, which was .4. And again, we'll play port 8080. But on this side, we're going to be a listener. We won't need an address because this is our listener, right? So if we do that, what am I missing? Port, oh, listen, sorry. There we go. Let's go ahead and kick this off. We're going to go ahead and not save that. Cool. So now this pod's compromised. Oops. Who am I? Yeah, we got nothing. Oh, I see why. Filter got me. Okay, let's take a look at this. Follow TCP stream. Hey, look at that. There's my screwy text that I messed up. Who am I? Okay, cool. So we know the reverse shell works. Let's encrypt it. TLS, and as you can see, this guy's still kicking off. You do need to restart it with the TLS flag. But I will say this binary works great for persistence. I've definitely injected this into compromised hosts, let it do its thing, and it'll call back every 5 seconds. You can change that 5 seconds. It has to be done in the source code though. TLS, no answer. Go ahead and open our listener. Let's go ahead and turn that on. Okay, who am I? TLS. Let's follow that TCP stream. And as you can see, encrypted. Great. Oh, that's fun. Okay, let's go ahead and kill that. So let's go back to our drawing. And I'll show you why that is in 1 second. So we just covered bind and reverse. If you need to pause the video, take a look to understand what just happened there. Yeah, this should be a good mental diagram. Now what we're going to do is we're going to go over bind and reverse shells. What we're going to do is we're going to have our pod as our victim, or sorry, our pod is our attacker threat. We'll use the actual operating system of Kali as our SOCKS5 proxy, and then secondary pod will be our victim. And same thing with the reverse shell. We're probably going to use Windows for the reverse shell just to kind of show how that works. Okay, let's jump back into here. So let's do this. Let's go over here. Here's our Kali host. Config. Okay, so we see it's a 243 address. So we're going to need to remember that. We're going to do proxy. Let's do port of, alright, 8181. So we need to hit that port. So what we're going to do is we're going to do the same listener. Oh wait, let's do the bind shell first. Okay. Now for the bind shell, we have to reach out, right? And then this guy will be our compromised host again, and we can set this one to just port 8080. We're going to listen on that. If we go through that, of course it'll work because we already know that. We'll explain through the Windows host in a minute, but let's try and bounce over to the 192 address and see if we can get in. 8181. Missing port. Oh, my bad. And supposedly that worked. It's there. It supposedly works. But now let's kind of mess with this, just to prove it works. And as you can see, that didn't work. Let's turn on our listener. Hopefully, if I coded this right, it will fail because the SOCKS5 proxy is not running. Hey, look at that, it failed. Let's turn that on, kill that, and prove. Like, obviously, the endpoint's not going to be there. Hey, look at that. And then the SOCKS5 proxy is like, yo, that doesn't work. Turn this back on. And we're there. Okay. Now let's add some windows. What we're going to do, we're going to bring this VM over here. And we have this tool called Windows Task Job.exe. I think Defender's on too, huh? Yeah, okay, so it's still there. Oh, it's thinking. Did we get caught? Awesome. Okay, so I need the IP address of this guy right here. Proc net going to do is we're going to open up reverse. Let's see, where are we at? No, listen. That's all we're doing, right? Listener opened. Okay. I'm going to turn this proxy back on. And what we're going to do is we're going to, oh, that's right, go back to Windows. And what we'll do is we will grab address. Didn't stick. .4. Port. Oop, all right, there we go. So we just need to add the port, which was 8080. Okay. And then we need to add, let's do TLS. Before I do that, let's add reverse. Makes it a little bit bigger. Now we'll add TLS, and then we need to add our proxy. The proxy is going to be that 192 address. Okay. Port 8181. And this is just to demonstrate you can bounce between networks, right? So let's say we have a compromised front end web server, whatever you've broken into, and then you have another network in there. You need to use something to bounce between victims, whatever. I'm bringing this up because we mainly do this in containers, and this works great. Okay, so now that that's running, that looks good. We've got our SOCKS5 proxy running, and we've got our listener running. So this should work. 8181. Oh, we got it. Who am I? And we're in. And we're still running. Defender's on. Great. All of that worked out great. Now the next bit. We could do a file transfer, which I'm inclined to do. So let's just do that. Okay. Let's bounce back over to Windows. And as you can see, it'll keep going. Okay. So, oh boy. Come on. There we go. Got it. Nailed it. Okay, so let's do a file transfer. Because we need some kind of file on this Windows host for whatever reason. So it's going to work just like the reverse shell, but in this case we're downloading a file. It works on file upload, but we're just going to do download for now. So let's do download. And we will do that same IP address. We will do port 8080. Let's do, I guess we should do the file name, huh? File name. Let's do savefiles.exe. And of course TLS. And let's get our proxy in there. Okay, so that's working. We need to get the Windows side set up, or sorry, the Linux container set up. So let's do this, file transfer. Let's do listen, because we're a listener, right? I don't think we need to worry about the file name just yet. And TLS. Oh, and port, right? 8080. All right. So our proxy's running. our file listener is there, and we have our file. Let's hop back to Windows. See what happens. No connection can be made. Actively refused. Connection to server. Ooh, okay. So that needs to be fixed. And I bet I know why that is. Oh, I'm an idiot. I just saw it. Notice how we had download, right? Download just means that this binary is going to act like a client and it's going to download from a server. I'm an idiot. I'm sorry. Let's try that again. And we go. I literally spent like 5 minutes digging through the source code like, why isn't this working? Idiot. Alright, cool. So, yeah, download, right? File name. So, my bad. We're back. Okay, so we're going to go through here. Again, file transfer, download. We've got our proxy running. Hit go. And it didn't work. Where did I screw up? Host name. Oh, I've got it set to host name. See if we get a hit. Oh, we got a hit. And it looks like it downloaded successfully. We can see over here, sent successfully. Let's see if it actually is true. It is. Oops, my bad. C H. Hey, look at that. So we just got our Reaper ransomware uploaded, and now we're going to kick it off. I should be doing this administratively, but I'm not going to. And yeah, that works. And so far, Defender's not freaking out on me. Cool. Alright, well, I guess that's it for this video. I'm going to bounce back over here. But yeah, SOCKS5 Proxy works great. I will mention that I have used this on containers. One thing that really caught me off guard is if you don't have network segmentation, some kind of restrictions. I think Calico is a good way of going, making sure only namespaces speak to certain networks, all that fun stuff. If you don't, what will happen is you'll deploy a pod, or you'll see a deployed pod to a container that has zero service, right? Well, on the Kubernetes networking layer, it's still exposed. So if you can get this binary on a compromised container and turn on that proxy, you can bounce between pods and really screw with the SOC, so that way they can't understand where the infection really exists. You have to have some way of monitoring that networking, so that way you can say, oh wait, every time this file executed, sure it was that pod, but if we look at the networking, there's an incoming instruction from this pod over here, or even an external C2. Anyways, hopefully that's helpful. Probably clear as mud. If you have any questions, hit me up.